Hey there y'all, today we're going to look at 4.5 on the point slope form. And so in this section the objective is that you'll be able to use point slope form of a linear function to be able to graph the function and model real world linear relationships. This comes out to two standards for us. This is FIF4 and FIF8. Again, we've been dealing with FIF4 for a while. FIF8 is being able to translate between different but equivalent forms of a function to reveal and explain different properties of that function. And again, we're going to be talking in linear functions at this point. And so the first thing we want to look at is being able to know what the point slope form is. And to do that, I'm going to show you how it comes about. And when we look at this, we've got the slope formula here. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, what we can do is we can take x sub 1 and y sub 1 and a general xy. So we've got one specific point and one general point, and we're going to plug that in. And so that manipulates our formula to now be y minus y sub 1 over x minus x sub 1. So the 2's have gone away is what's happened. And then it says to solve such that the y terms are on their own side. Well, to be able to do that, we're going to multiply by what's in the denominator. And so to get rid of this denominator, x minus x sub 1, this and this will cancel. And x minus x sub 1's over here. And so what we're going to get is we're going to get m times x minus x sub 1 is equal to y minus y sub 1. Now, we normally like the y's to be on the left-hand side, and so flipping this around, y minus y sub 1 is equal to m times x minus x sub 1. This formula here is the point slope form. So, again, this formula here is the point slope form. Now, the way we use it typically is that we're going to be given one specific point, so like the order pair 5, 7, and we're going to know the slope, and we'll plug it in there, and that's point slope form. But sometimes we're given 2 points, and if we're given 2 points, we need to first find the slope of the line between them. But let's see how we're going to use this to deal with graphing functions. So in this first example, we're going to be given a point and the slope, and asked to write the equation of the line in point slope form. And so remember that point slope form is y minus y sub 1 is equal to m times x minus x sub 1. Remember that any time that you're using a formula, write the formula out first and then substitute into it. And so we're given this order pair 3, negative 4. And so this will be my x sub 1, y sub 1. And it has a slope of 6. And remember, slope is your m, so m is equal to 6. And so we're going to substitute where everything belongs. Y minus negative 4 is equal to 6 times x minus 3. And so the double negative on the y side will become positive, so y plus 4. We're not going to distribute because we want to leave it in point slope form. And point slope form keeps the parentheses around that x minus x sub 1 part. And so this is the final answer. Y plus 4 is equal to 6 times x minus 3. And so I want to show you a couple of things about this. Our slope is still visible to us here, right? Our slope of 6 is still our slope of 6. But look at the 3, negative 4 we had here. The 3's here and the 4's here, right? In point slope form, both the x and the y are opposite of what we're used to seeing. We had a negative 4 here, but in the final answer it says y plus 4. And over here, we had a positive 3, but it says x minus 3. And so we're going to see that those sides will change based on what we've substituted in. So here's example B. Write an equation in point slope form of the line that passes through the point negative 1, 5 and has a slope of negative 3. So I want you to pause the video here and try this problem, and then unpause it and see if you've gotten it right. So pause now. Alright, so now that you've tried that problem, let's see if you've gotten it right. And so we're going to start with our point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. This is our x sub 1 and our y sub 1. And of course, our slope is equal to negative 3. And so substituting everything in, y minus 5 is equal to negative 3 times x minus negative 1. Be careful with the double negatives. And so y minus 5 is equal to negative 3 times x plus 1. So that is what you should have gotten. Again, if you got it, great job. If not, go back and see where you made your mistake. It might be a sign issue or where you put in your x and your y. Make sure you put those in the right spots. All right, so let's look at example 2. In example 2, we're given the equation in point-slope form, and we're asked to graph the line that it represents. And so we're having to pull out the information that we're given in it. And remember, in point-slope form, you're going to be given a point and the slope. Remember, the slope's going to be the easy part. The slope is right there in front of the parentheses, so the slope is 2/5. Whatever line I've got, it's going to have a slope of 2/5. So every time it rises 2, it's going to run 5. Rise 2, run 5, right? The point, remember, we've got to pay attention to the signs. The signs are always going to be opposite of what you see. So your x sub 1 is hiding out here. Your y sub 1 is hiding out here. But remember, it's opposite of what you see. And so it's not going to be minus 10 or negative 10. It's going to be a positive 10 for the x. And for the y, it's not positive 3, but negative 3. And so when we're graphing this, we're going to take our point, 10, negative 3. And so that would be at 10, negative 3. So our point is here. And then my slope is 2/5. That's what we had up here. And so that would tell me to go up 2 and right 5, but that takes me off my graph. So I have to reverse both directions. So if it was up and right, it's now going to be down 2, left 5. And I go down 2, left 5 again, and I end up here. And I can continue that pattern one more time, and we get a nice line coming through those points. And so, again, use your slope to your advantage. Rise and run. And if you need to reverse, you reverse both pieces. So if it was up and right, reverse of up is going to be down. And instead of right, I'm now going left, because I still need that same line drawn. Okay, so let's go ahead and look at example B, and I want you to try that one on your own. So in example B, we've got y minus 3 is equal to negative parentheses x plus 2. I'm going to give you one hint here before I have you jump in and do this one yourself. Remember that your slope is sitting here, right? But there's no number there. So there's just a negative sign, right? So if there's just a negative sign sitting there, what number could go in front? It's a 1. So my slope is equal to negative 1, and my point, remember this is your y sub 1 because it's on the y side, and this is your x sub 1 because it's on the x side. So x is negative 2, y is positive 3, and so I want you to pause the video at this point, plot this, graph it, and get your line and see if you've got the same line that I do. So pause the video now. All right, so let's look at where this line should be. Well, I've got the point negative 2, 3, so that's going to take me here and then positive 3, so that's this point here. A slope of negative 1 is the same as negative 1 over positive 1, so it's going to be down 1, right 1, down 1, right 1. Or I can reverse those and go up 1, left 1. And so with those points, we end up going through like so. Okay, so that's our line there. And again, our line would extend on forever. We put arrowheads on both ends of this. Okay, so again, if your line looks like this, your point at negative 2, 3, and then your slope being negative 1, so it's sloping downward, that is the correct line. Let's go ahead and look at example 3. So in example 3, we're given a graph, and we're given 2 points that are on it. Now, you're not always going to be told that, hey, here are 2 points to use, but we can figure most of this out as we're looking at it. So we're given the point negative 3, 4. We're given the point 2, negative 1. To be able to put it into point slope form, I've got to be able to use the point slope form. So y minus y sub 1 is equal to m times x minus x sub 1. Well, I've got a place to put one of these points, but I need a slope. So before I can plug into this, I've actually got to plug into the slope formula to find the slope of this line. Now, we could also go back to what we did in the slope section and see how far do we go down, how far do we go right. And so we're going to go down 1, 2, 3, 4, 5. So we're going down 5. We're going 1, 2, 3, 4, 5. We're going right 5. And so my slope would be negative 5 over 5, which is negative 1. And if we do the slope formula, we'll also see that be the case, because we can do the negative 1 minus 4 over the 2 minus negative 3, and that gives us negative 5 over 5, which is, again, negative 1. So we're going to take this slope, either value, it's the same value, right, and one of the 2 points. Now, sometimes, and especially on like standardized tests, they're going to tell you to use one point or the other. But if they don't tell you which point to use, you can use any point along the line to satisfy the point-slope form of the equation. And so I'm going to choose this one. I'm going to choose this as my x sub 1 and this as my y sub 1. And so I'm going to get y minus negative 1 is equal to negative 1, because that's our slope, times x minus 2. Simplifying the double negative, we get y plus 1 is equal to negative 1 times x minus 2. This right here is our final answer in point-slope form. Now, we're going to talk in the next section on slope-intercept form, and sometimes we might want to convert this over to that form, and we'll talk about that more next section. But for today, we just want to get it into point-slope form. All right, so let's look at example B on this. And in that example, we're going to see that we don't always be given the graph. We could also be given just 2 points. So let's see that. All right, so here's example 4. It says write an equation in point-slope form of the line that passes through the points 5, 1 and negative 9, 3. And so we're not on the graph here, so I can't, just see what is my rise and run quickly on the graph. We've got to go and plug this into the formula and figure out what is the slope first. And so x sub 1, y sub 1, x sub 2, y sub 2. And so 3 minus 1 over negative 9 minus 5. So that's 2 over negative 14, which reduces to negative 1/7. Now, when we plug into the point slope form, y minus y sub 1 is equal to m times x minus x sub 1. I can use what's already labeled the x sub 1 and y sub 1, or I could choose to use this one. It doesn't matter which point I choose unless it tells me to use one or the other. I'm going to choose the one that A is already labeled x sub 1, y sub 1, but also is already both positive. And so y minus 1 is equal to our negative 1/7 times x minus 5. This is the final answer in point-slope form. That's it when it comes to those. Find the slope, plug it in, simplify any signs, and you're done. So we're going to look at example 5 here and look at an application of the point-slope form, and that's going to be it for this lesson. So in example 5, the word problem is this. You are designing a sticker to advertise for your group. A company charges $25 for the first 100 stickers and $7 for each additional 100 stickers. Write an equation that gives the total cost in dollars of the stickers compared to the number in hundreds of stickers ordered. And we want to find the cost for 2,000 stickers. Now, I want you to pay attention to the wording of this. There's a little bit that is different about it, because we want the number of stickers, not just that, hey, the number of stickers is this, but the number is in hundreds. And so what that means is this. If I say that I have 2 of these, it really means that I have 200 stickers. Okay? And so let's see what that equation is going to be. Now, we weren't given the equation here, but we have all the information to be able to write this. And so y minus y sub 1 is equal to m times x minus x sub 1. So here's what happens. The 25 is the initial charge for how many stickers? 100. So my order pair, what's the cause and effect? I have 100 stickers. So I'm not going to use 100 because remember, if I have 2 for this, I have 200 stickers, right? So I'm going to use 1 to represent 100 stickers. And the cost of that is $25. And then I'm told for each additional 100 stickers, it's $7. This is my slope. And so my slope is going to be 7 over, not 100, but because remember stickers are in hundreds, so 7 over 1. And so m is equal to 7, or 7 over 1. And so y minus the 25 is equal to the m, which is 7 times x minus 1. And so what does this mean? So again, the 1 is the first 100 stickers, the 25 is the cost of those first 100 stickers, and then the 7 is how much each additional 100 stickers are going to be. And so what does the x represent? The x is how many additional packs of 100 that I'm going to have. So if x is 5, I bought 500 stickers, right? And then 5 minus the 1 will give me a 4 to multiply in here. And so let's see the second part of the problem, because this is the equation. So that is the answer to the first part, part A. Part B says find the cost of 2,000 stickers. Well, 2,000 is 20 hundredths, right? So I'm going to plug in 20 for the x. And so we're going to get y minus 25 is equal to 7 times 20 minus 1. Y minus 25 is equal to 7 times 19. 7 times 19 is 133. We will add the 25 across, and so y is equal to 158. So what does that mean? That to purchase 2,000 stickers, that's why we plugged in the 20, right? It will cost $158, because remember, word problems require what? Word answers. So again, make sure you plug this in correctly into the appropriate spots. Okay, so that's the lesson for today. If you've got questions, make sure you put them in your Google form, and I will catch y'all next time.